Hello, welcome to my channel. I'm here to do my 100 Leetcode challenge. And today we have Leetcode 136, single numbers. So given a non-empty array of integers nums, every element appears twice except only one. To find the single one. So here is input array. So we see 221. So 1 is the only one that is single. So we output 1. And here, 2 and 1, they are repeated in pairs. Only 4 is single, so 4 is output. So if it's here's 1, then return 1. For this question, we first use a hash map to calculate and accumulate all the repeated one. So we check through the whole hash map and see which one's individual. So we see if that accumulation is 1, then that one is the single one. We can start with that and then we can optimize it with the follow-up. Let's take a look. Now we have map, make that integer an integer. Call map equal to hash map. So now we have hash map. Then we now for in every integer inside the nums, we will put that inside the map that I equal to map dot get, or I plus 1. So what does that mean? Get or default is if map doesn't have I, so the default will be 0. And then if now I doesn't have it, and so we set the default as 0 plus 1. That means it have 1 right now. So if map inside if I inside the map already, then we'll get the I number in the hash map and plus 1 to be the new number of I inside the map. So in here, we look through 2, we put 2 in the map, but map doesn't have it. So will be 2 and start with default is 0 and plus 1. So will be 2 and 1. Now we loop to second integer. Since 2 is already inside that map, so it will be map.getI, which is here. The result is 1 plus 1. So we have 2. Capture 2 and the frequency of 2. So this is key. This is the value inside the map. That's what we want. And after that, we capture all the frequency. And then we can loop through the map by calling dot entry. We have integer entry inside map dot entry set. So now we take out all the entry inside that map and check if entry dot get value equal to 1, and then we return entry dot get key. So we return the key as that number. And in here is only have one solution, then this should be correct. Else, if we don't see anything, we return -1 as a default. Okay, hash map. So that's it for this question in here. But now this is one of the solution. But look at the follow-up right here. we are using linear runtime by running through all individual integer inside the array, but we are kind of using extra space. Originally, I think this is not extra space because it's kind of hard to say. The size is not that big, but we can optimize it by using another solution, and it's called, let me call this, and we have byte-wise operation. So byte-wise operation means if decimal 3 in byte-wise will be 1, 1, right? So 1, I mean 2 in byte-wise will be, this is like binary, and this is decimal. So for this byte-wise operation is when 3, I think this sign 2, XOR will become, let's see here, the result of XOR is 1 if 2 bits are different. So comparing this bit and this bit will be different. So here's 1, and 1 and 1 is no different, so it's 0. So the result of this one will be 0, 1. It's also 1. But the good thing is we can check if any same number that XOR itself returns out 0. Because the byte-wise will be the same. So when they do the XOR operation, it turns out 0. It will turn out 0 all the time. So you can imagine this question. If 1 and 1 do this operation, it will be 0, and 2 and 2 do this operation will cancel out. So only 4 will be left, or 1 in here will be left, since this is after this operation. You can imagine this 2 will come out as 0. So anything 0 and byte-wise to another like 101, something like that, it will turn out exactly same as 101. So which is this number. So this is the individual single number that we're looking for. So we just return this one as a result. This is the idea of this question. And let's take a look at this code. So now at this time we have output equal to 0, and we loop through the array. So the result output is equal to output this operation nums I, and then the output will keep updating with this new number. Using this byte-wise operation, the end, you will see the individual single number left for this answer. Okay. And this is way faster and using less memory, I hope. In here, yeah, I hope this answer the questions. If you have further questions, please comment it below, and I will see you in the next video. Bye bye.